Hello, everyone. This is Muhammad Swinam. Today we have a special guest. Today we have our exceptional educator, Mr. Mark Richard. Everyone know Software Architecture Monday. And today we are not going to speak about Software Architecture Monday. We will take the hard questions with Mr. Mark. So, hello, Mr. Mark.
Hi, thank you so much. And hello, first of all, and thank you so much for having me on your podcast. This is exciting.
It's my pleasure. It's my pleasure. So I know the majority know Mark, but I want you to introduce yourself.
Oh, sure, absolutely. So as you had just said, Mohammed, my name is Mark Richards. I've been in the software field for quite a long time, 36 years, as a matter of fact, more than probably some of you listening are actually alive, and 26 of those as a software architect. So I've had a lot of varied experience. Most of my work has been in consulting, and until fairly recently, now I'll say recently, the past maybe 8 years, I started to transition more from hands-on work in projects to do more training and conferences and workshops. I just kind of felt like I had all of this knowledge, and it was really doing no one good by me being stuck in a development team. So I started to do more training, kind of transitioned my career that way, which I just really love. I'm passionate about teaching and training and always wanted to do that. I've been busy the past couple of years writing some books with my friend Neil Ford, and two of those in particular, the fundamentals of software architecture and also architecture, the hard parts, which we just recently released about a year and a half ago. So yeah, we're currently working on another book, the O'Reilly Head First Software Architecture, which hopefully will be out the end of this year or probably in January.
Can't wait. Can't wait. I have the two books and I will be waiting for the new one.
Awesome. That's great.
Okay, perfect. So, Mark, today we need to ask you a couple of questions. And these questions, I call them the hard questions. And I call them because we have a lot of confusion in the industry around these questions itself. And I would like to start with what we just finished. What is software architecture from practical point of view? And what is the difference between software architecture and software design?
Yeah, boy, what a common question. It's easy to say, oh, that's an implementation problem, or oh, that's design, or that's architecture, but it's hard to understand what we exactly mean. And but I'm going to go beyond what I typically do in my Software Architecture Monday videos and all that, and really talk about more of a practical understanding of software architecture. But I am going to include some other pieces, though. Let me start with the traditional and typical metaphor. And then I'm going to show you how that breaks down to really describe architecture. But what we're really talking about is the overall structure of the system, how it's put together. Now, when we talk about a distributed architecture, like microservices, for example, or event-driven architecture, or even service-based, it's easier to think about the structure because we've got deployment units, being those services, and we have communication between those and kind of to those services. So picture, if you will, the picture I'm kind of building. So think of all these boxes sitting around, all these lines between them. Maybe different databases that are associated with a domain, or like in microservices, kind of attached to that service in a bounded context. But all these things that I've just described kind of form the structure of the system. Well, that's pretty easy to kind of get a sense of, but what about a monolithic type of system,
Indeed.
something that's like in a modular monolith or like a microkernel or even a mobile app or just a kind of a simple web app or even the traditional n-tiered layered architecture, which still exists. I mean, what then does architecture mean? There's still a structure there, Mohammed. There still is how the code is really organized. And it boils down to how code is organized into components. Now, I'm going to say a component is basically like a logical building block of the system. When we write code, here's a great way to describe this. So when we write code, whether it be a class file or maybe a py file, if we're doing Python or whichever, where does that code reside? In other words, it's a file, and we have to stick it somewhere. Now, a lot of times it goes into a directory structure, within our Git repo, for example. But in Java, it might be a package structure. That code might sit in a namespace in .NET, but ultimately it's in some sort of directory structure somewhere. Well, if you think about that directory structure, we put class files together because they kind of do a similar function. I mean, all of these maybe handle our payment processing for a credit card. There's a good example. It may be 5 or 6 different classes. So we put those all together in a directory, which again might be a namespace or package structure, something like that. That in itself defines a building block, a component of the architecture. So isn't it interesting? That's the structure. And because as an architect, what I'm concerned about are not how the individual class files all communicate and are coupled between one another, but how those packages, how those namespaces, those building blocks are all connected. And that's one way to think about the overall structure of the system. And so now that I've kind of defined it, though, I'm going to go to the old-fashioned metaphor, which is physical buildings. Because a lot of times we'll say, well, okay, I see that a physical building has an architecture. If you look at a skyscraper in the city or even a small office building, that's an overall structure. I like to think of the rooms within those as components, the building blocks. And so we do have an architecture and we implement it by basically painting walls and putting furniture in and actually kind of making it livable or workable if it's an office building. This is a very traditional metaphor, but I don't like this metaphor. And I'll tell you why. Because a lot of people think, well, why should I really care about architecture, what it is? I mean, can't we just start coding? Like we're agile software development. We should get a requirement and start coding. So is it really still relevant? I mean, should I care about architecture? And I love answering this question by saying, well, would you allow a bricklayer or an electrician to start just simply going it alone? Let's just go with the flow and start building a house. You've saved up for that new house, and you've got a vision of what it might look like. Would you rely on those kind of people to build your beautiful house? And the answer, of course, is no. I mean, there's structural elements. There's load on different floors and the ceiling. You don't want it come crashing down. You want it to be structurally sound. And that's kind of where the metaphor has its strength in terms of the structure, holding up your code, forming your code. You want it to continue working. Even though the house is functional, it might come crashing down on you. However, is architecture really important? And so, yes, we don't want bricklayers or electricians or plumbers or even just a contractor who can say, I can build a house, designing our brand new house for us. But there's another reason this metaphor fails, because you see, architecture is iterative. In other words, it changes as our requirements change. It changes as we learn more about our environment. So unlike a building, we can't just kind of have an initial plan and say, well, we'll wing it. We'll figure out the number of floors, or you can't do that in buildings. But in software, this is a normal and correct course of action with architecture. So that's kind of where
actually this is very important point. Very important point. The software architecture change from time to time. It's not something that we did and we cannot touch it.
Exactly. Yes. Yes. So this is now you and I both agree that this is a key point. Getting business stakeholders, project managers on board with this point is sometimes really hard because their impression or perception of architecture is that of like a building. Well, you can't go and change the structure every iteration. You can't keep moving things around. It's supposed to be stable. This is our foundation. Don't keep changing it.
Yes, yes.
And the problem is, the perception is that us architects really don't know what we're doing. And that's a problem. But I believe it's exactly the opposite. If you are constantly or continuously changing your architecture based on new requirements, you're learning more about the system, just like in any kind of agile software development, then the architecture needs to be malleable and flexible enough to be able to accommodate and change along with it. If you're not changing your architecture, what happens is that architecture becomes misaligned from the implementation, and it won't scale, it won't be reliable, it won't be available or fault tolerant or easy to change, easy to extend. So these are some of the things when we think about the term and definition of architecture. But I really want to address that second point, which was that difference between architecture and design. I did one of my lessons. As a matter of fact, Mohammed, it was as of this recording, it was just a couple of weeks ago, I think.
Indeed, indeed.
I did a architecture kind of versus design. So I'll let everybody watch that. I won't necessarily reiterate that. But one of the things which I didn't talk about in that 10-minute video was why it's important to distinguish between architecture and design. In that video, I think it was lesson 168 or 7.
I will put the video link in the description.
Beautiful, thank you. I kind of talked about some criteria to decide where in a spectrum a decision is, whether it's architecture or design. The reason why it's important is because too many times as architects, we tend to make decisions that we really shouldn't be. We should be deferring to development teams to make those. And this creates what's called in architecture a control freak architect, one that tries to control every part of the implementation process, is making low-level decisions. And really, these kind of architects are effectively stealing the art of programming away from developers. But the same is also true from development teams. A lot of times development teams will make a particular decision and not understand the significant trade-offs or consequences of that decision. And consequently, by making that decision, treating it as a design or implementation concern, can completely derail any sort of characteristic of the architecture: scalability, performance, fault tolerance, whether it be overall reliability, extensibility, any of those. And so the reason why it's important to know where in the spectrum your decision lies is really to know, should I really be making that decision? Or should, we should
This is
always
the
collaborate.
second questions actually, and now we come to it.
Yeah.
So this means as a developer, I have to understand exactly what is the difference between software architecture and software design. And based on this, I can go to the architect asking for consultation.
Exactly. And that is the key, Mohammed, exactly what you just said. You see, there should always be collaboration between a software architect and a development team to work together to make these kind of decisions. So I'm not talking about any sort of island of isolation, but really who should have the responsibility. And the way you put that, Mohammed, is just perfect. Because as a developer, I'm like, this sits kind of in the middle of the spectrum. There's some architectural parts to it. I should probably go talk to an architect and just make sure that this is a sound decision. That's really where the why piece of why it's so important. Yeah, exactly.
Do we have something in between that I might not be aware 100% if this is architecture decision or design decision?
Yeah, there's a really good example. So we're going to use microservices for this next new system we're building. Okay. We don't need any of these criteria to realize that's about architecture. That's the overall structure of our system. I want to replace our PDF rendering engine. Okay, that's not architectural. We really don't need all that criteria, but very few decisions actually fit right at those ends. Most of them, Mohammed, you're exactly right, are right in the middle, that gray area of saying, I'd like to split up a particular service or maybe consolidate services together. These are structural changes, but they may carry some significant trade-offs or may not. The level of effort is kind of medium. These are the things that fall right in the middle. And to your point, should not be made in isolation, definitely from a development team. If it starts to, that slider bar starts to move a little bit towards that architecture side, that's where that collaboration is so necessary. Even just to get advice from an architect. Those are the times when to do it. So we talked about the how, but when to ask for help is to utilize those tools that I showed in that video to really say, yeah, this is the time to go talk to the architect.
Yes. Are you against having a decision by developer to something related to software architecture if he really know what he gonna do?
Oh, sure. Mohammed, so many companies have the same problem or this common problem. There's not enough architects to be able to solve all of the architecture problems or answer all the architecture questions or even to do architecture, whatever that means. And the problem is it comes to a point of economies of scale. And so a lot of companies are currently trying to distribute the architecture role to development teams. To be able to empower senior developers to understand more about architecture, understand what the implications or consequences and trade-offs are, and to be able to make the same kind of decision that an architect could make. I call that, and a term, architectural thinking. It's looking at a problem not from a development standpoint. I may see as a developer how I might design all the class files and what algorithms I might use and whether I'm going to use threading or not. And these sort of implementation concerns. That's seeing a problem from a developer's eye. But architectural thinking is seeing that same problem from an architect's point of view. Does it change the structure of my system? How am I going to still maintain our levels of scalability and responsiveness and fault tolerance that we need? How am I going to analyze, or no, how am I going to identify the trade-offs between option A and B, and how to analyze those trade-offs? And that's all about that architectural thinking. And I've been doing a lot of work. I would say the past 5 years, especially during COVID, of working with companies to kind of do architectural thinking, help development teams understand architecture better, so that we can start distributing this role. Absolutely, yeah.
Perfect. Speaking about one point you mentioned on software architecture, which is dealing with stakeholders and the architecture decision record, how can we convince them? I would like to ask you about exactly the ADR. How should it be?
Yeah, I love this topic. I could talk for hours on ADRs, but I won't. I won't talk too long. But ADRs, architecture decision records. Let me go backwards just a little bit, Mohammed, because I get very excited about this topic. You see, back in 2011, and before, I knew something was missing. As an architect, I was missing a certain piece. And I did a lot of reflection and realized I'm constantly in meetings. That's like all I was doing was scheduling meetings. And I started to ask myself, why am I in all of these meetings all the time? And so I started to reflect, and also when I was in meetings, why am I doing this? And the reason I was in so many meetings was because I was trying to understand why somebody made a certain decision. And then it dawned on me, I could look at diagrams and I could see how stuff should be done. If I'm asked to analyze an architecture, I could look at the diagram and see exactly. I could visualize the whole system. But the reason we were having all those meetings was because I didn't understand why you made a particular choice. And that was my epiphany when the light bulbs all go off and the cherubs start singing above your head, and there's all the songs and glorious things happening. That was my epiphany, was that understanding why you made a decision is far more important than how it works. And as a matter of fact, Neil and I, in our book, The Fundamentals of Software Architecture, coined 2 laws of software architecture. The first law was that everything in software architecture is a trade-off. And the second law was why is more important than how. So why did I talk about that anecdote? ADRs. So what a great vehicle for being able to tell everyone, developers, other architects, business stakeholders, product owners, sponsors, why I made a certain decision. Because it's one of the sections of an ADR. The decision section is the place to put all of your justifications. And it's just a wonderful way of not only documenting your architecture decisions, but telling people why you actually made this decision. And then the consequences section is the second most important section in an ADR, because when I make a decision, there will always be a consequence. Maybe I'm sacrificing some performance to be able to get better security and access control because there's going to be latency. But that is more important. Well, where is that documented in the world? Well, it's up here, but no one sees that. Maybe there's a consequence of additional cost or additional effort. So these are really powerful pieces. There's two golden rules of architecture. And I'll talk about both of them, but the first one's the relevant one here. If a developer doesn't know why you made a decision, they're less likely to agree with it. And the second golden rule, if developers aren't involved in a decision, they're less likely to follow it. And
Completely agree.
Yeah, and so how do you communicate all of this rationale, the why piece? And ADRs is really that vehicle. And so that's why I like them so much. Whether you use an ADR or a document, this is the artifact that you can also use to crowdsource a particularly important decision. I'm going to choose to use messaging between our microservices instead of REST. I don't agree with that at all. I think we should use REST. I mean, it's microservices. Between services, we've already got a RESTful infrastructure. Why aren't we just using REST? Do you see? That decision alone will cause a lot of controversy.
Yes.
So there are specific reasons. So crowdsourcing this in the status of an ADR allows you to say, this is request for comment. Here's my decision, my rationale, the consequences, the trade-offs. By next week, comment on it. Maybe I'm missing something. And it does encourage people to read those ADRs. But also, it gets people, just really helps them embrace the concept. Boy, there's so much to talk about on here, but those are the main, that's the value really of those architecture decision records. I would challenge all of the listeners here to try it out. Take a major architecture decision. Now, it doesn't have to be a new system. Take the system you're currently working on as an architect. What was one of the major decisions you made? And write an ADR for it. Try it out. This is one way of starting to, quote, document an existing architecture that maybe you don't have documentation, but also it allows you to justify and find the why piece for why things are done. Chances are you'll get an architect like me who might come into your shop or company one day and say, well, this is a problem right here. And this area of the architecture is not scalable. We should change the order in which we do things. Well, I might make that suggestion. And I might, based on that, cause the system to completely crash and burn. And why? Because I don't understand why it wasn't done the way I'm suggesting. This is why having that rationale is so important, because people will start making suggestions. Oh, we should change this around. We should use REST. We should use messaging. Maybe there's a reason why the original architect didn't choose that. So it's also for maintaining that integrity of the system. Yeah.
But that means this kind of EDRs, at the end, we will have logs of EDRs, and it's not only shareable with technical people, it's also with business.
Yes.
So we have to choose the right words, the right terminology that everybody can understand.
Which do you remember that first law I mentioned? Everything in software architecture is a trade-off. So I just violated one of my main rules in trade-off analysis, which is avoid over-evangelizing any given type of product, solution, platform, technology, language. Well, I just fell into that trap myself because I got so excited. I over-evangelized the use of architecture decision records. However, let's talk about those trade-offs because you're right. How do you manage hundreds of ADRs? What decisions should be in an ADR? What ones shouldn't? Should ADRs replace your existing documentation or should it augment it? Which systems will use ADRs and which ones don't? And so we start to see some of the challenges with using architecture decision records. If half of your documentation and decisions and rationale are buried in Word documents somewhere on a file system no one can find, and half of them are in a Git repository where your ADRs are, we still don't have a complete picture. And this is exactly the challenge. It in a lot of cases is something that needs to be fully embraced as documentation and not to supplement it, but really replace architecture.
Something like Confluence, for example.
Yeah, exactly. Now, the storage of these, there are some tools that do store them in Git repos and help automate the process. But a lot of times they're stored alongside the source code. And I don't care to do that. There's trade-offs. I like the fact that it's close to the code, but not many people have access to your development repo.
Indeed.
And so what I generally like to do is still use Git, but I create a global repo that everybody has access to that contains the architecture decision records. And that helps the problem a little bit because it gains that accessibility. Of course, that means your business stakeholders need to know how to use Git.
Indeed. Correct. Mark, you mentioned multiple times right now microservices. And today microservices seem to be a trend. Regardless anything else, microservice. Why all of this hype?
There's a Mohammed, I have to laugh because there's a well-known anti-pattern called the jump on the bandwagon anti-pattern. All of our competitors are using microservices. Why aren't we? And so we're kind of forced into this architecture style that's really, really hard. I have been in the industry for 36 years. 36. I have implemented and designed every architecture style that's out there. I can tell you, and I've been doing microservices for a little over 10 years now. I was a very early adopter of this architecture style. And I could tell you without hesitation, Mohammed, microservices, this thing is the hardest thing I have done in my career so far. That's how complex it is. So it's a great question. Well, if it's so complex, why all the hype? Part of it was the same kind of momentum that service-oriented architecture, SOA, had back in 2003. It took the world by storm. Mohammed, I remember being in restaurants in the city and overhearing the words SOA at the table next to me by people. It's like I couldn't go anywhere without avoiding SOA. It just was everywhere. And it had that same kind of hype. It was something new. It solved all the world's problems, and we should embrace this. And yes, I agree. There was a lot of hype around it. Part of that hype, in my experience at least, was, again, that problem of over-evangelizing. We have some serious problems and continue to have some serious problems in our industry right now, because business and technology are changing at rates faster than they ever have before. New releases of software, of platforms, replatforming, app modernization projects, the lack of skill in COBOL, and the lack of influx of COBOL and RPG developers is causing a lot of risk in these systems. There's change everywhere. And in business, the marketplace is so volatile that businesses are pivoting at rates 10 times faster than they did 20 years ago. So businesses have learned how to change quickly. And now, in today's world, it's IT. It's our architectures that are the bottleneck. So this was one of the primary drivers, the hype. Now we have an architecture style that allows us to change so quickly that I could deploy, not even theoretically, but practically on a daily basis. By partitioning my system, my business domain and problem into single purpose functions that are all separately deployed, if I need to add a new function, I add it, I drop it into my ecosystem, whether it be serverless or containerized, and I'm all ready to go. I don't need to retest my entire system. As a matter of fact, if I make a small change, the only thing I have to test is that small service. I could do that within 20 minutes and have full, complete regression of that service. So these were the promises that we saw with microservices. And if we have an architecture bottleneck, and this architecture style can help us move and pivot faster and change faster, then this is something to embrace. And all those things, by the way, are true about microservices. So why are we moving away from microservices now? Well, because we realize, well, those things are, well, true. They're also highly theoretical. You see, we could take an entire system and break it apart into several hundred different functions. Yeah, we could do that. But can we do it with the data?
No.
Oh, right.
No.
That's right. We have to break apart data to form physical bounding contexts, don't we?
Yes.
Yes,
Yes.
we do. And suddenly we see the first biggest issue with microservices: data, the data problem, because most large legacy systems are monolithic relational databases, not easy to break apart. We have foreign keys, we have triggers, we have stored procedures, we have all these other artifacts besides tables. And once we start breaking things apart, now we have to communicate between those services to get data I no longer own. And pretty soon it looks like a big bowl of spaghetti.
Yes.
It
Yes.
just doesn't work. So yeah, I have noticed a slowdown in the high adoption rate of microservices. I've noticed companies being more cautious, teams being more cautious about stepping back and really saying, is this the right architecture for us? And it has actually given rise to more hybrids now. Not every portion of an entire system has to be microservices. This was, one of the first mistakes, one of the many mistakes that all of us made when starting to embrace microservices back when. We have a new system. Every bit of it needed to be microservices, and we found that it was just too hard. But does the admin portion of your system that handles all all the maintenance and name value pair maintenance and all. Does that have to be microservices? No. Does your user registration need to be microservices? No. Back-end functionality? No. And so we realized that hybrids are really coming into that hype curve now, and pure microservices starting to shy away from a little bit.
But it will not gone. So we will mix the hybrid, will mix microservice with something else.
Yes, yes.
And everybody has to understand that you will pay a lot if you're gonna decide to use microservice.
Yes, it is extremely complicated and also very costly, not only from the licensing problems, Mohammed, but also just reorganizing teams, breaking apart data, the decisions that you have to make cause delays, and this is all translates to cost. That's why it's so expensive and so complicated.
Speaking about this part specifically, and I have noticed this, that some blogs recently published, and when I checked the source of this, I found it's coming from AI. Mm-hmm. So some people start to ask AI, ChatGPT, the generative model, the LLM, if you can please guide me to do some software architecture decision or not. What is your opinion about this?
Oh, of course you can guess. I definitely have an opinion about this. Yeah, this is a very common question, Mohammed, about the whole AI craze. Talk about a hype curve. But here's what I like to equate it as. And I want to talk about very briefly AI in general, but then how it can apply to software architecture. And some results I've seen out of about 6 months of research I have personally been doing with AI and software architecture. So back in the day, I'll call it many decades ago, we have accountants, and we still have accountants today. What before the advent of spreadsheets and electronics and stuff, what did accountants do? Well, they wrote in books, manually wrote into general ledgers, a ledger being an actual piece of paper with a pencil. And then they sometimes had 2 books, double book accounting, to make sure that those 2 books were always in sync. And then they had people who would go and verify all the numbers, re-add everything. Okay, that's the way we did accounting. Then we had things like VisiCalc and spreadsheets, like Excel and these sort of things. Well, the question to you is, did spreadsheets replace accountants?
No.
The answer, of course, is no. No, they did replace those army of people who manually added up the numbers to re-verify them, because now we can automate that. But they didn't replace accountants. No, they made their lives easier, faster. They were able to actually go home at night. So I'm going to equate that with developers. Developer is an accountant. That function is still absolutely needed and will always be needed. However, it won't replace a developer. It's going to be a tool that developers can use. Now, let's talk about software architecture. I want to design a system. Well, which should I use? Microservices, or should I use event-driven? And what's the answer? The most common 2 words. It depends. There you go. Well, the trick of a software architect, or the goal, or the role, the duty of a software architect, is to say, right, but it depends on what. Now, that's the art of software architecture. So there's a classification between knowledge and wisdom. And AI tools that we have now are really good at knowledge, but not so good at wisdom. And these are 2 different kinds of, well, classify both of them as kinds of knowledge. So can I have AI build me an architecture? Well, what is it going to do? Well, it's going to get the most statistically probable components and statistically probable protocols and solutions. Is it the right one for my particular case? In most cases, not. It's a general architecture. So how can we leverage AI in architecture? And this was a question I posed to myself of March of this year. Once the big hype started with AI, of course, I have a ChatGPT account, and I start doing all these prompts and everything. And I said, but how can I use this as a tool? Because most of the work I do is wisdom, not knowledge. I leverage knowledge, but it's that art. So I started to see some possibilities. Can I ask an AI engine, do you see any risk with my proposed architecture? I can ask an AI engine, do you see any bottlenecks? Will this architecture scale to 2,000 concurrent users under load with less than a second response time? But I ran into a roadblock because an AI engine doesn't know my architecture. And so my research really did back up. It's like riding a horse and just pulling back the reins and saying, whoa, whoa there. The first thing I got to do is to make sure that the AI engine can understand my architecture. How can it do that? There are a lot of tools that allow us to digitize our architecture. Oh, things like Archimate, things like PlantUML, Structurizer for the C4 model by Simon Brown. These are three really good examples. I would not call them standards, but Archimate is trying to become a standard, at least within a small community. But if I can electronically specify my architecture, then I can have an AI engine understand it. And that was the first part of my research. And it was, well, let's say 80% successful. The fun I was having was to feed it a PlantUML specification XML.
Of course, this is the first thing I got to my mind.
Right?
How did you do this?
Yeah, and say, generate the structurizer code for me. And it would. Generate an Archimate diagram from this description. And it would. When I fed it into Archimate or C4 or Structurizer or PlantUML, it was missing some elements. It wasn't perfect because it's just statistically saying, yeah, statistically, this is what the element would probably be, but it was in the wrong format. So AI doesn't really understand the spec. All it's doing is generating it from statistics. But it was some promise because simple architectures, it was able to understand and ask and correctly come up with bottlenecks. For example, I did a very complex microservices with a single database. And sure enough, the engine did come up and say, your database will be a bottleneck. I was like, there's some promise here of helping us as software architects look for areas of risk or possible areas of risk, things that we didn't see. Now, I did go one step further and I asked the AI engine, I said, what would you do to mitigate this risk? And guess what the answer was? Caching. Beautiful. Because that's one of my go-to solutions. I would have probably suggested that.
But I think this is still knowledge.
It is still knowledge, yes. Because I said, well, what kind of cache would you use in this case? And the answer was exactly wrong. 100% opposite. It had suggested distributed caching because it has much better performance and reliability over in-memory, which is exactly the opposite of what it should have said. So I kind of got deflated and said, well, let's keep starting over and describe more. But the point is that there's some promise here. But it's interesting, Mohammed, because AI really has been kind of a game changer and people are excited about it. And it really has given rise to this new role that I'm starting to see in companies, and it's called a prompt engineer.
Yes, yes.
This is the person who knows exactly how to ask a particular question. And like the Google searches that we used to do back 10, 12 years ago, or even more, where it was the art of searching, how to answer those right keywords. Well, now the same thing exists with AI, is how to properly give the context to an LLM so that we can get an appropriate response. And this now is becoming an actual title.
So I can think of AI from your conclusion that AI can be like a semantic search engine, semantic smart search engine that I can ask to give me answer based on context, but the final decision will be mine based on the wisdom I have.
Exactly. Yes. So it could help us. Yes. As an accountant, I need to balance my income statements and balance sheets and all this, and spreadsheets can calculate that for me, but I still need to do that and move things around, and a spreadsheet cannot do that for me. So yeah, it could provide us, at least my projection, my theory is that as software architects, it can help us look for anti-patterns, known anti-patterns. That's knowledge. You're right, Mohammed, that's knowledge. It can help me identify bottlenecks, possible risk areas. The more information I give it, the better the answer could be. So this is some of the promise that I see of it helping us as kind of an assistant.
Yeah. What is an exciting discussion, Mark?
Yeah,
I would like to finish this with one last question. What is your opinion about the trends we have today, and what is your recommendation and advices?
Yeah, I love talking about emerging trends because it's always that little crystal ball, but it's things that at least I'm seeing in the software architecture world that are really trends that are helping us. And there's quite a few. As a matter of fact, the first trend I've already mentioned, and that was the reemergence of embracing tools like Archimate, like PlantUML, like Structurizr, to just name three, that allow us to electronically convey our architecture or represent our architecture. We're so used to diagrams and documents and even ADRs to kind of describe our architecture. And the more electronic all of that is, the better AI is going to be able to assist us as an architect. So that is now kind of starting to be an emerging trend. I'm not the only one, by the way. I've talked to a lot of colleagues at conferences and just little one-off conversations like we're having here about this topic. And I'm not the only one to have come up with the fact that, yeah, we need an electronic representation of our diagrams so that an AI engine can see it and understand it. So that is reemerging as a trend now to kind of embrace these kind of diagramming tools. But I think another emerging trend, which has been emerging for several years now, has been the use of automated governance through what are called fitness functions. This is something that my friend Neil Ford and Rebecca Parsons and Patrick Kwa had identified and coined in their book several years ago, Building Evolutionary Architectures. Engineering uses fitness functions all the time, but we tend not to use them for architecture and software. Why? No reason why we should, and we now do. And this is starting to really become an emerging trend. to be able to answer the question, we just changed a lot of code in this current sprint or this current iteration. Did we impact the architecture in any way, structurally? Did we impact scalability, availability, fault tolerance, its overall reliability? We could have these fitness functions continuously running in a production environment to identify changes. We just upgraded our network. Did it impact our architecture or any of those characteristics? And so we're finding them more and more useful. And there's a lot of tools that we can consider fitness functions, or we can write them ourselves. But I think another trend, actually two more trends, a quick one, data mesh is becoming a trend, not a fad. Now, how do you tell the difference between a trend, something we should look at and embrace, and something that's a fad? Oh, that'll go away. Well, one of the ways of identifying a trend is to look at the landscape of how many companies, product companies, commercial companies are either developing tooling for this trend or are embracing it. And sure enough, data mesh is in that camp. But this is a way of basically wrangling analytical data, particularly in a microservices ecosystem. This is when we start breaking apart data, it becomes hard to do reporting, and it becomes harder to do machine learning, data analytics, any AI stuff, because it needs all that collective data. And this is one of the answers. Boy, we could do a whole podcast, Mohammed, on data mesh at some point. That would be fun. But the last trend, I would say, is this concept of what's called an architectural quantum. Now, one of the things that we're trying to get hold of is when we've got a complex system and we think about the structure, the architecture, is it all, even though we have a distributed architecture, is it all coupled together so that when one piece fails, all of it fails? Well, that seems to be a big problem. When we talk about integration in a company of multiple systems across divisions or departments, or even across major systems, one system fails and all of a sudden other systems start crashing. You know, we have trouble with coupling. So this concept of an architectural quantum is rapidly gaining in popularity and also understanding. And if you think about physics, a quantum is the smallest possible unit of matter that can exist. Well, all right, little asterisk, used to be, but and some physicists still claim that it is. And that's what the quantum is. It's the parts of a system, all of it, the user interface, gateways, web servers, services, databases, that can stand alone as a separate, independent artifact from other parts of the system. And the more we understand breaking apart our systems or partitioning them that way, the more reliable they actually become. And this gives us justification for breaking apart user interfaces, for breaking apart data, to get better overall reliability when our systems continue to crash. So these are some of the trends that, boy, like I said, we could do an hour-long podcast on all of those. But in summary, those are kind of some of the trends that we that I've seen important.
Hopefully, I will again bother you to ask you about another podcast to discuss this exciting trends.
That would be wonderful.
Mark, I am super happy to have you today and to have this great discussion with you. Thank you so much. And really, I learned a lot from you right now, and I will be waiting for more from you. And thanks a lot.
Excellent. Well, thank you so much for having me on the podcast.